Okay, for number 9, a child has 4 different math books, 2 different dictionaries, and 3 different storybooks. The number of ways he can put them on a bookshelf if books of the same kind must be kept together. So here the idea is to arrange these 3 different books, but each book has 4 different formats, and then 2 different for dictionaries and 3 different storybooks. So to solve these problems, you can see the number of math book here is 4, so it will be 4 factorials arrangement, and then multiply by 2 different dictionaries, it's 2 factorials, and then 3 different storybooks, so it's 3 factorials. And this 3 factorials is the arrangements of this kind of books, 3 kinds of books, yeah. So math, dictionary, storybooks, or the arrangements can be story first, math, and then dictionaries, or dictionary first and then story or math, and etc. It will be 3 factorials. So if we multiply all together, it will get this one, 1728 as the number of arrangements of this problem. Okay. Okay. For number 10, this question is about permutation. So the values of n in the equation Pn comma 4 equals 12 times Pn comma 2. So here remember P is represent permutation. As you know that the formula of permutation is if Pn comma 4, it will be this one. So n factorials over n minus 4 factorials. And Pn comma 2, it means the permutation of 2 of n. So the formula, it will be n factorials divided by n minus 2 factorials, and then times 12 here. So this is equal to this, right? But here you need to find the value of n, right? So we can use arithmetic here. So after you expand this P and PD using the formula of permutation like this, as I mentioned before. So what you do here, you can do cross multiplying here. So this one you can multiply by n factorials, and this n factorials uh, you can multiply by this. So if you write to the left, it will be like this, right? So n factorials times n minus 2 factorials and n minus 4 factorials times n factorials. And this is numerator and denominator. It has the same value, so you just simply cancel it, right? Cancel. And then equals 12. After you cancel here, so remains only n minus 2 factorials divided by n minus 4 factorials equals 12. Now, from this, you can expand this n minus 2. If we expand, so after n minus 2, it should be n minus 3. And then after n minus 3, it should be n minus 4. So why we stop until minus 4? Because the denominator here is n minus 4 factorials. All right, so you can simply cancel n minus 4 factorials, this one. All right, and then remains only n minus 2 times n minus 3 equals 12. Nah, this one is the factors of quadratic equation. After you multiply one by one, it will be like this: n squared minus 5n plus 6 equals 12. And then you move 12 here to the left, so remains here minus 6, right? So plus 6 minus 12, so minus 6. So here it will be n squared minus 5n minus 6 equals 0. And then if you factorize, it will be n minus 6 times n plus 1 equals 0. So the value of n here, it will be n equals 6 or n equals minus 1. And then why we choose only 6? Because n here represent a natural number. So only n equals 6 that satisfy. Understood, yeah? Because this permutation is a real problem, so it will be impossible if the number is negative. So we choose n equals 6 here for this equation. Okay. Okay, number 11. SMA pribadi is choosing the leader and the vice leader for OSIS out of 6 people. The question here is the number of ways they can choose the leader and vice leader is, okay, these problems actually you can solve by 2 ways. The first way is using this uh, method. So for the leader here, it will be 6 possible people, right? So to choose a leader, it will be 6 possible people. So it's 6, and then for choosing vice leader, it will be 5. Why 5? Because we already choose 1 people for leader, right? So remains 5 here. So simply 6 times 5, so equals 30. Or you can use permutation formula. Just you want to arrange, choosing and arrange 2 people as a leader and vice leader from 6. So it's 6, 2. So a permutation of 2 of 6. So by using this formula of permutation, 6 factorials over 6 minus 2 factorials. So 6 factorials over 4 factorials equals 6. If you expand until 4 factorials, right? 6 times 5 times 4 factorials. And then you divide by the 4 factorials here. So you can cancel it. So remains only 6 times 5 equals 30. So this is the answer for number 11. Number 12. Which of the following is equal to 10 times 9 times 8 times 7? In terms of permutation, because the options are permutation here, right? So to answer it's very simple. You just see here is 10, right? So it's 10, and then we calculate here 1 2 3 4. So it's only 4 here. So it's permutation of 4 from 10. So it's C, the answer. Okay, and then for number 13, now in a meeting there are 10 people not knowing each other. In order to get acquainted, they need to have a handshake. Okay, the number of handshake it takes to get everybody to know each other is, so here the problem is about handshaking. If you have 10 people, and how many handshaking will be? All right, so this one is the concept of combination. Why? Because in handshakings, what happened there? If you do handshaking, it should be you and one other people, right? So it will be handshaking consists of 2 people. So it means the event is choosing 2 people out of 10. So it's only choose, not ordering. So this one is using concept of combination. Yeah. So look the difference between permutation and combination. Permutation it should be choosing and arranging on ordering, but for combination is just choosing here. So here handshaking is combination because it's only choose, not range. So this one is choosing 2 out of 10 using combination. So the formula will be like this. 10 factorials over 10 minus 2 factorials, and then times again 2 factorials. Okay, so different with the permutation. 10 factorials over 10 minus 2 is 8 factorials, and then 2 factorials. And then again, we need to solve this one, right? So you expand 10 minus 9, 10 times 9 times 8 factorials. Why stop until 8 factorial? Because we have 8 factorials here, right? So after that, you just cancel 8 factorials here, and then remain 10 times 9 over 2 factorials, right? So 10 times 9 is 90, and then over 2 factorials is 2 times 1, which is 2. So 90 over 2 is 45. So in handshaking from 10 people, it will be 45 handshaking here. Okay, so this one is using concept of combination. Next question is number 14. This one is simple, yeah. The number of ways can be made choosing 4 members of a committee from 6 people is. So this one is just choosing 4 out of 6. So it's combination. So using a formula of combination, choosing 4 out of 6. So 6 factorials over 6 minus 4 factorials times 4 factorials again. And then equal 6 factorials over 6 minus 4 is 2 factorials. And then 4 factorials again. And then you expand. So 6 minus 5, 6 times 5 times 4 factorials over 2 factorials times 4 factorial. So 4 factorial per factorial you can cancel. So remains 6 times 5 over 2 factorials. Again, 30 over 2, which is 15. So this one is choosing, so using combination concept. 15. This actually a hard question, so you have to be careful of solving this because it will have many steps. So a quiz team of 5 students is to be selected from 6 boys and 4 girls. The number of possible teams that can be selected in which there are more boys than girls. So here, this one you need to choose 5 students from this combination, 6 boys and 4 girls. And then with the restriction here, to select this, it should be more boys than girls. Okay, so let's do it one by one. Firstly, if you think like this, so because you have 6 boys plus 4 girls, it will be 10 people, right? And then you simply think that choosing 5 out of 10, that is true. But if you think like this, it just be outcome in order to find the probability of this event only. So if you just think like only until here, so it will be incorrect. So because it will this one is the information in probability, yeah. But here the condition is not probability, but still finding the uh, possible arrangement or possible selecting here. So firstly, you need to consider the restriction here. Okay, to choose 5 students from 6 boys and 4 girls with this restriction where the boys is more than the girls. So this one, the possibilities will be this. We have 3 possibilities, the first, second, and the third. Number 1, you can choose 5 boys. So all 5 students are boys. It means we choose 5 boys out of 6 because the number of boys is 6, right? So it's combination of 5 from 6. So using the formula of combination, so we'll get 6 here. Okay, this is the first possibility. And the second possibility, of course, choosing 4 boys and 1 girl. Okay, remember boys should boys more than girls. So 4 boys, 1 girls. Still 5, right? Because we select 5. Okay, means we choose 4 boys out of 6 and choosing 1 girl out of 4. So using combinations, this is in 4 boys, choosing 4 out of 6 times choosing 1 4 from 4. Yeah, just because the number of the girls is 4, and then you choose only 1, and then you multiply using the formula of combination that we have learned in the previous. So it will be like this. You get 15 times 4 equals 60 when you choosing 4 boys and 1 girl. And the last possibility should be choosing 3 boys and 2 girls. Still the boys more than 2 girls than girls, right? So I mean we choose 3 boys out of 6 and choosing 2 girls out of 4 using the same way as possibility number 2, using combination like this, and then we'll get 20 times 6 equals 120. All right. So from these three possibilities, you add all the answer. So 6 plus 60 plus 120 will be 186. So this is the answer or the solution of this problem. Okay, so this one actually is not easy questions because we have a stage here. We have the restriction. It's not just simple selecting. Okay.